Chairman, delegates, ladies and gentlemen. Very good afternoon to you all. So today my topic is moving from control-based towards data-driven adaptive systems. What does that mean actually? So traditionally, processes have been controlled by traditional control systems, which are reacting to the disturbances in the process and finally controlling the process to come to the desired end quality. But then the need is that what if these systems could be smart enough to predict also and adapt themselves to those changes to give a better quality. So this journey has already started, and Indian pulp and paper industry is no exception to this. We have seen quite many mills already starting implementing this. So my journey with a few case examples today, I would like you to take through with me. Excuse me, can you please? Thank you. So here we see the integrated approach for smart manufacturing. The theme for this seminar was smart manufacturing and how automation supports that. So here at the bottom of the table you can see the various eyes of the process, which are the measurements. We have process controls, machine controls, condition monitoring systems, quality control systems, web inspection and etc. These all are important eyes to monitor the process disturbances, but then they are giving valuable values, but in silos. So the next step would be to integrate all these valuable information from all these systems into the modern available technologies, digital technologies, Industry 4.0, which has secure cloud, so that we can utilize this data for better management and control. So, what is the first step towards the semi-autonomous mills? It is the advanced process controls. When we talk to mill engineers, production people, quality people, and the management, the target is to have a good quality of product and quality product, and at the same time minimizing the raw material resources like fiber, chemicals, energy consumption, etc. So APC, when it is sitting over the basic eyes of the process, which are the measurements, it gives them an additional tool to optimize the process in an advanced way. Typical framework for autonomous operations. So we have, like the previous slide just mentioned about APC, that is the first stepping stone towards the semi-autonomous mills. But then alone, AI packages won't help that. There are systems like if you see the journey of the mills, initially they are normally partially automated. When we say partially automated, means localized controls and measurements. Then we go towards the fully automated. Semi-autonomous means when we are implementing the APCs. Then orchestrated, when we are deriving data from the APCs and utilizing it for the management purposes and of course the process optimization. And the final step is autonomous. So in this, when we talk about autonomous, that means all the data from measurements, APCs, that is being used by the modern technologies to optimize the process. So, APCs, they work in areas. Might be APC could be for a fiber line, for washing, for bleaching, for stock preparation, but they all are working in a silos. So we need to go from the local approach to the global approach, local optimization to the global optimization. So this is an example where there is a scheduled shutdown plan for the plasticizing plant for 8 hours, and the program, mill-wide optimization program, which is a combination of various measurements, EPCs, that automatically calculates what kind of levels for the white liquor are to be kept without disturbing the critical limits, and at the same time giving the maximum digester production. But then, process is dynamic. So, one plan doesn't work always. So, in this case, if you see, the scheduled shutdown for plasticizing has to be reduced to 4 hours, for example. So, single plan doesn't work. The model has to recalculate the best plan so that the inventories are kept at the same level, it doesn't go beyond the critical limits, and at the same time avoid the production decrease. So this is where we move from traditional controls to the intelligent controls. Now, what if we get prior information about our final product? So we are predicting the quality without actually the product being manufactured. The challenge in production is that we are producing something, then we are validating it from the laboratory. There is a significant gap between the laboratory results. In the meantime, the operator has nothing to rely upon. They just use their experience, use some safety factors. For example, in this case, the paper strength. They will use their experience and might be add an additional safety factor to keep the strength properties at that level. That can result in might be more fiber and more paper strength properties which are actually required. So that means we are spending more fiber and there is a cost to the mill. Similarly, if that target is below and we are then affected by the sheet breaks, poor end product quality. So this kind of smart applications, they help you to predict the quality and adjust the parameters accordingly. In this case, you can see here, if we are getting the real-time information on the paper strength before the paper is being made, 1 to 2% of savings for this magazine paper case were achieved, which relates to 1 million euros per year. So that's smart manufacturing. Now, the next step. What if, for a new project, we could envisage how the process would work. You see this yellow baseline. So this is the typical normal startup curve, where operators, they learn with the experience once the process or machine is started up, and then with the time they adapt and they reach the desired production level and quality levels. But when we talk about virtual commissioning, that means we are creating digital twins of the process. So before actually the machine or the process starts up, we are creating that twins. APCs are implemented, operators they learn on the model, and a faster startup when it actually happens. So you can see the kind of savings in this case. They were around 20 million euros for 1 year of production. So this is where the technologies help, and we can get optimized results. So we have talked about process, measurements, advanced technologies, APCs, but environment is an integral part of our manufacturing process. So without talking about this presentation would be incomplete. Government regulations are becoming stringent day by day, and it's our responsibility, like as a manufacturer or as a technology provider, to reduce the impact of the paper making or pulp making on the environment. So there are technologies available. You can have measurements at various locations of the ADP process. You can measure total solids, you can measure low solids, high solids, optimize your polymer dosage in the belt press, and that would give you a higher solids at the end of the process. And that high solids residual can be used as biofuel or other applications, which is like demonstrated in this case study. So this comes from a case study from Finland, though we had a case study from India as well, but unfortunately more data was not available. I would have loved to do that, but still this correlates with what we have done here also, and this can be done. So what was the target for the mill? So they wanted to increase the dry solid level after the belt press, optimize the polymer dosage, so that they can use that sludge into the boilers, and so higher moisture there would be like affecting their boiler performance. So they made all these measurements, and they had these sludge dewatering optimization programs in line. So that helped them, and the testimony from the customer is speaking about itself. So I think I will save more time. So quick summary, I would say, we have to, like, it's the call of the time. We all move from the traditional automation controls to the controls which are learning with time, adapting them with the data they have. And the quality of data, that is also important, and how to utilize that to the benefit of decision making, that is of the most importance. And at the same time, I would say once again that I have been associated with the industry from '94, and I have seen a lot of transformation myself also. So I am proud to say that our industry is adapting to these changes. Thank you so much.